Good afternoon to another person here. Today we are going to discuss about the new topic which is related to DT based CAD design. First of all, we have to discuss about the what are the basic types of CAD available and how we are designing the CAD profile. Can anyone tell me about the previous class discussion?
So last class we have discussed about the different kind of mechanisms. One was industrial design, and another was mechanism, and simple theory as well.
Actually, in our previous class, we have to discuss about the different types of machines as well as the different types of mechanisms already we have to discuss. So today I am going to discuss about the CAM design. In our second unit, we are having the CAM design. First of all, we are having the different types of CAM and follower. In our mechanical types, the CAM and follower both combined we have to use that providing the motions between the any components like IC engines or different sectors we have to use this kind of CAM. Once the basic components of CAM and follower is one is CAM and another one is follower. So CAM is having the different shapes. Based on the shapes, it can be classified into different types like cycloidal CAMs, circular CAMs, and elliptical CAMs. So different types of CAMs are there. And based on the applications, we have to select any one kind of CAM. Okay, for example, we have to do one part from the one place to another place. We have to choose any kind of material handling equipments like conveyors, belts, ropes. So, a number of mechanical components are there. Instead of the material handling equipments, we have to select the cam and follower mechanisms, which is used to move the workpiece or move the some part from one place to another place. As well as likewise, we have to classify the follower into different types. So follower also having the different types based on size and based on the shape, it may be classified into different types. Okay. So first of all, how we are constructing the CAM profile means it is first we have to construct the displacement diagram. After that, we have to construct the CAM profile. So first we have to construct the displacement diagram. It can be classified into three types. The first one is for uniform velocity type displacement diagram. Then second one is for SH, simple harmonic motion type displacement diagram. And third one which is uniform acceleration and deceleration, or otherwise uniform retraction and retardations. So this is the basic three classifications of CAM displacement diagrams. From that CAM displacement diagrams, we have to construct the CAM profile. Okay, so first there are major three concepts which is available in our CAM profile. First one we have to consider the RER, which means R means first one the rise, second one is well, and third one is return. So in our either case the problem they have to mention the CAM profile. We have to consider the CAM which will be starts from the rise of some degree. So we can add this 3, we will get the 360 degree. So CAM profile we have to consider the whole revolution is 360 degree. Okay, this is the basic general concepts which will be incorporated in our CAM profile. Okay, can anyone one small activities we have to conduct? If anyone tell about the different components and in their CAM profile mechanism.
This is how does the CAM work by a simple mechanism. This is a DC motor runs by AC current and alternated by direct current DC current. This motor linked to cam shaft, and the follower is in top side. When the cam is raised, the spring is compressed and the follower is in the head of 180 degrees. The cam is in top.
Follower is upward direction.
This is a dial gauge to how the degrees are rising or lowering to measure it. See that the spring is compressing, the follower is in the top of the rise. This is the return. In example, This is the inlet valve opening. The spring is compressing, the valve is open and close. Resembling IC engine. The dial gauge are fixed in the top of the engine.
So actually he said is very correct. The AC motor which defines the cams. So the cam define which is connected to the cams. So automatically the cam will be rotated means the follower will be moved to the either upward direction or downward direction. So it may be basically the R it will be denoted as the RDR. There are different types of cam profiling we have to draw. Basically we have to select it as the RDR, which means first one is rise, first 180 degree, the follower will be rise. After some 90 or 100 degree, it will be an ideal position. So after that, we have to return the again the ideal position. So that will be mentioned as the RDR. Okay. Can anyone tell about the different applications of CAM which will be used in other mechanical industries?
Sir, used in the EC machine and the textile machines and next built-in machines used.
So he exactly says correct different types of textile industries and other component transformations and food packaging industries and different types of automobile and IC engine sectors that maybe we have to prefer the cabin follower mechanisms. So anyone please summarize the today's class what we have discussed.
CAM components in CAM applications pin types we are seeing today.
Okay, nice. So this will be our design thinking based CAM and follower mechanisms which will be used in our different types of mechanical as well as the automobile sectors. So in our next class we have discussed about the case studies which is related to our CAM analysis. Okay, thank you.